Welcome back. In our last class, we talked about how glasses could be used to produce imaginary images at the near point and the far point of a person's vision, and this helps a person see when they have farsightedness and nearsightedness. A magnifying glass works in very much the same way as a farsighted person's glasses, although now we're going to use the magnifying glass to look at objects much closer to our eye than the near point. By bringing the object inside of the near point, it looks much larger than an object at the near point, and so that means that the magnification, it's much easier to see. A simple magnifying glass is made of convex lens, and the center is thicker than the sides, so this is a converging lens. So, as you hopefully remember from before, as you bring an object to the focal point of a converging lens, or a mirror, so converging convex lens or a converging concave mirror, the image moves to infinity, and so the closer the object is to the focal point, the larger the image. We have to be careful that the image switches, because the image switches from real to virtual when you move through the focal point. But the key point is that the object moves closer. As the object moves closer to the focal point, the image gets larger. If you're struggling with this, you might go back to the simulations and then just move your object through the focal point, and you should be able to see right away that the image gets very large. So, if we want to figure out the magnification of a magnifying glass, we want to compare the largest we can see an object with the unaided eye and compare that to what we see in the magnifying glass. To figure out the magnification, we will find the angular magnification. So how much larger is the angle that the object covers in the glass versus the angle with the unaided eye? So the largest possible angle with the unaided eye is when we put the object at the near point. If we draw our triangle, the angle theta is equal to the opposite over the adjacent, and the opposite is the height of the object, and the adjacent is the distance, which is the near point distance. Notice we are using the small angle approximation here, where the sine of theta is equal to theta when talking about angles that are very small. So that gives us a value for the angle that we see with the unaided eye. For the angle seen in the magnifying glass, the maximum magnification is when the object is exactly at the focal point. This is an approximation. Usually if an object is exactly at the focal point, the distortion in the lens is too much, and it's hard to see a clear image. You'll have to move it slightly off the focal point, but for an estimate this is pretty good. Okay, so the angle at the focal point is the height of the object divided by the distance to the focal point. That means that the magnification is the angle prime, and that angle, if we use the small angle approximation, is the height divided by the focal point. So it's the height of the object divided by the focal point. And so if we do that, then we can combine this together to find the magnification, which is the angle theta prime over theta, and that is then equal to the height of the object times the distance to the near point divided by the focal length of the magnifying glass divided by the height of the object. Notice the height of the object here cancels out, so that means our final magnification here is the near point distance divided by the focal point distance. So that means in general, the smaller the focal point, the larger the magnification, and which sort of makes sense, right? That the smaller the focal point, the closer you can move that object to your eye, so that means that the effective magnification becomes larger. Okay, so yeah, and it is kind of interesting that the magnification depends on your near point distance, but it should sort of make sense that, the worse your eyes are, the greater the effective magnification of a magnifying glass, because you'll have to hold it further away in order to look at it. Okay, so you have a few questions to do, and next we're going to discuss the telescope. Good luck.